Hello viewers, I'm called Apia Asumeni Joseph, and in this video we are going to solve some problems on circuit theory. And those questions we've taken them from the Aquila textbook, which we've been using normally. Okay, so in this question we are told to find angle SQY. Now, angle SQY, as we know already, is found beside angle YQR. Okay, but how are we going to find it? Okay, we know that there is a property which says that the angle formed between a chord and a tangent is equal to the angle in the alternate segment. Okay, so normally I do tell my students that when they get a question like that or a problem involving a tangent and a chord, they should look at the arc that forms the angle between the tangent and then the chord. Okay, so when we look at this arc, it is forming an angle here. So we can draw our arrow. Now, where exactly is this arrow pointing? Which angle is it pointing? It is pointing exactly at angle YXQ. So it is pointing this angle. So it means that angle YSQ is also going to be 54 degrees. Okay, so we have our 54 degrees here. Okay, now that we have angle YSQ, we have a triangle, and in the triangle, two of the angles in the triangle have been gotten. So it is easy to get the other angle. How do we get it? We just sum up the two angles and deduct it from 180, because the sum of interior angle in the triangle is equal to 180 degrees. So here it can be calculated as 54 plus 41. 54 plus 41 gives us 95. Okay, so when deducted from 180, I'm going to get 85 degrees. So it tells us that 85 angle SQY is 85 degrees. So in this question we are told to find A, okay, and we know that we have line PR, and because line PR passes through the center of the circle and touches either side of the circumference of the circle, we can say that line PR is a diameter. And there's a property which says that when a diameter subtends an angle at the circumference of a circle, that angle is 90 degrees. It is only when a diameter subtends an angle at the circumference of a circle that angle gives us what? 90 degrees. Okay, so we have angle PQR. This diameter is subtending an angle at the circumference of a circle at position Q to be what? 90 degrees. Okay, now there is also another property in plane geometry 1 which says that the sum of two opposite interior angles in a triangle gives us one exterior, gives us the angle of one exterior. Okay, so we can say that A plus 90 should give us what? 4A plus 12. Because normally I used to tell my students that if they find it difficult to be able to use this property in plane geometry 1, which says that the sum of two opposite interior angles in a triangle, the sum of two opposite interior angles in a triangle gives us one exterior, they should try drawing L along those two angles. Okay, now when we draw this L from this side to this side, it appears outside here, which tells us that this angle, when we sum these two angles up, we are going to get a result of what? This angle. So normally that's what I advise my student to do. Okay, so we have A plus 90 degrees gives us what? 4A plus 12. Okay, so I have 90 minus 12 equals 4A minus 8. It gives me what? 3A. Then 90 minus 12 gives me what? 78. So dividing both sides by 3, 3 goes into 7. Then 3 goes into 18. I'm left with 1. That 1 is 10. When added to 8 is 18. So 3 goes into 18, 6. So I have 20. So A gives me what? 26. Okay, now let's continue. Now in this diagram we are told to find the value of y. Now in finding the value of y, how are we going to do it? Okay, there are certain conditions surrounding y which we have to take in consideration first. Okay, now we know that we have triangle RST. This small triangle here is an isosceles triangle, and as we already know, the base angles of an isosceles triangle is equal. Okay, we have two angles at its base, and those angles are what are equal for isosceles triangle. So angle what SRT, which is 60 degrees, will be equal to TSR, will be equal to that angle. So definitely we are going to what get 60 degrees here, because for an isosceles triangle, two of its base angles are what are equal. So we have 60 degrees here, but we are also going to get 60 degrees here. So angle TSR gives us what 60 degrees. Okay, now we can also use another approach which says that the angles on a straight line add up to 180 degrees. Okay, so since we have an angle here which is 60 degrees, the other angle we can obtain that by deducting 60 degrees from 180, and that angle gives us what 120 degrees. Okay, so we are going to get 120 degrees. Now let's assume that there is a chord, an imaginary chord, joining PR. Now this chord subtends angle at opposite what segments. Okay, those two angles will sum up to be 180 degrees, and that's one of the properties of circle theory. Okay, so we have to bear in mind when the chord subtends angle, two angles at the circumference of circle, and they are in opposite segments, those two angles sum up to 180 degrees. So it tells us that y degrees we have here plus 120 will be equal to 180 degrees. So it gives us that, it tells us that y plus 120 degrees equals 180 degrees. So we have y equals 180 minus 120. It tells us that we have what 60 degrees. So here y gives us what 60 degrees. Okay, so we are back in what we've been doing. Okay, so we are on question 4 now, and as you already know, we have a diagram here. Okay, and we are told to find the value of p. Okay, now it's not difficult. We are only going to use one property in the circle theory problem. Okay, now we know that, let's assume that a line joins A to B. Okay, line joins point A to B, an imaginary chord. Okay, let's assume that. Now we can see that this chord is subtending an angle at the center of the circle. At the same time, it is also subtending an angle at the circumference of the circle. Because of that, there is a property in circle theory which says that when the chord subtends an angle at the center of the circle, it is twice the angle it subtends at the circumference of the circle. So we know that the angle at the circumference of the circle, which this chord subtends, is p. Okay, we are told to find p. So it means that twice of p, which is 2p, gives us 82 degrees. Therefore, dividing both sides by 2, gives us 41. So we are on question 5, and we are told to find the value of p in question 5. Now let's assume that there is an imaginary chord joining A to B. Okay, now this chord is subtending an angle at the center of the circle. Okay, let us also assume that the same chord subtends an angle at the circumference of the circle. Okay, now this chord is subtending an angle at the center of the circle. At the same time, it is subtending an angle at the circumference of the circle. And we can say that the angle P we have here, when summed up to this angle, should be equal to 180 degrees. Now how do we get that angle? Okay, we can easily deduct 280 from 360 degrees, because angles that meet at a point, this angle meet at a point, angles that meet at a point add up to 360 degrees. So if you're able to get this angle, we can easily use the property which says that when a chord subtends an angle at the center of a circle, it is twice the angle it subtends at the circumference of a circle. Okay, so we can use that analysis, or we can use that property to get what we want. Okay, so we have 280 degrees here. Let us quickly deduct 280 degrees from 360. It's 360 minus 280 degrees, which gives us what? 80 degrees. Okay, so it means that we have 80 degrees here. Now this 80 degrees, twice of the angle this chord subtends at the circumference of the circle, gives us the 80 degrees. So we know that, let's assume we have B here. Let's assume we have an angle B here. Then twice of B is equal to 80 degrees. We divide this out by 2. Get what? So B gives us 40 degrees. So the angle B we see here, the angle B there is 40 degrees. It's 40 degrees. Now the chord which we assumed joining A to B, okay, we know that a subtending angle at opposite segments, and those two angles when summed up gives us what? 180 degrees. So it tells us that P plus 40 will give us what? 180 degrees. Therefore we have P equals 180 degrees minus what? 40 degrees. Okay, so that gives us what? 140 degrees. Question 6 now, and we are told to find P. Okay, now let's draw an imaginary line to join A to B. Now since we have joined A to B, we've seen that we've gotten a chord. Now when a chord subtends an angle at the center of a circle, we know that it is twice the angle it subtends at the circumference of the circle. So here, this chord is subtending an angle at the center of the circle. Okay, to be O. Let's call it O. The same chord is subtending an angle, or is making an angle at the circumference of the circle. So it means that twice of P gives us what? The angle we have here, which is 40. Okay, 40 degrees. Okay, so it gives us, tells us that 2P gives us what? It's equal to 40 degrees. Then divide this out by 2. P is equal to 20 degrees. You can see in this diagram that chord AB is subtending an angle at the center of the circle to be 90 degrees. At the same time, it is subtending an angle at the circumference of the circle, which is P. Okay, we are told to find what the value of P. We know that the angle the chord subtends at the center of the circle is twice the angle it subtends at the circumference of the circle. So it tells us that we have twice of P, which is this chord subtends an angle here, and it is twice the angle the same chord subtends at the circumference of the circle. So twice of P is giving us what? 90 degrees. Okay, so when you divide this out by 2, get 45 degrees. So B is equal to 45 degrees. We are told to find the measures of the angles of triangle PQR and then triangle OQR. It means that we are finding all the angles. Okay, that is angle RPO and then POR, ORKO. In fact, we are finding all the angles. Okay, so in this question, you can see that there's a line from the center touching the circumference at Q. We can call that line as the radius. Okay, there's also another line joining O to R. That line is also a radius. Okay, now we know that radius in a circle, when we have as much as many radiuses in a circle, all those radiuses are going to be the same, or they are going to have the same value. Okay, so we can say that these two radius are forming what? A triangle. Okay, which is triangle what? OQR. Okay, so because we have two of the sides of that triangle to be equal, or to be radiuses, then we can say that that triangle is an isosceles triangle. Because that triangle is an isosceles triangle, two of its base angles are what? Are equal. So if you have 60 degrees here, then definitely angle ORQ will also be 60 degrees. So we have 60 degrees here. And then we can say that there's a line joining what? P to Q, and it passes through the center of the circle. Okay, this is the center. That's why it has been noted with what? O. In circle theorem, anytime you realize that in the middle of the circle a letter has been what? Indicated as O, it means that it is the center. Okay, so this diameter, okay, a line joining P to Q passes through the center O, so it means that that line PQ is a diameter, and the diameter subtends an angle at the circumference of the circle to be 90 degrees. So this diameter here is subtending 90 degrees at the circumference of the circle. Okay, so it means that if the whole of this angle is 90 degrees and we have here as 60, then here too will be what? 30 degrees. Okay, because when you deduct 60 from 90, we get 30 degrees. 30 degrees. And we also have two radiuses forming a triangle here. So this triangle POR can also be considered as what? An isosceles triangle. Therefore, two of its base angles are equal. So we have 30 degrees here. Now, the sum of two opposite interior angles in a triangle will be equal to one exterior. So when we sum 60 plus 60 degrees here, we should get what? An angle here. Okay, and 60 plus 60 gives us what? 120 degrees. So we have 120 degrees here. So when we are told to find what type of triangles are here, that's triangle PQR, PQ, and then R. Now PQR, as we have here, we have PQ, we have 30, 60, and then 90. When a triangle has one of its angles to be 90 degrees, it means that triangle is what? A right angle triangle. So it means that triangle PQR is what? A right angle triangle. And then also we are told to find what type of triangle is OQR. Now OQR, we have to find one of the angles of what? We have to find one of the angles of what? OQR, which is this side. Which is this side. And angles on the straight line add up to what? 180 degrees. So when we deduct 120 from 180 degrees, we should get the other angle. Okay. So when we deduct 120 from 180, we get what? 60 degrees. Okay. So we are getting 60 degrees in the three angles of what? Triangle OQR. Since all those angles are equal, okay, we can say that triangle OQR is an equilateral triangle. We are told to find angle ABD. Okay. Now, looking at this question, you can say that angle COB is equal to 60 degrees. Okay, since it is 60 degrees, you can say that vertically opposite angles are equal from plane geometry 1. You know that if COB is 60 degrees, then AOD will definitely be 60 degrees. Okay, so we have 60 degrees here. Vertically opposite angles are equal. Now, we can also use a property in the circle theorem which says that when a chord, let's assume you have a chord here. When a chord subtends an angle at the center of the circle, it is twice the angle it subtends at the circumference of the circle. So it means that twice of what? Angle ABD give us what? Angle AOD. And angle AOD, as we know, is 60 degrees. So we have twice of angle ABD. When you divide this side by 2, you get angle ABD becomes equal to 30 degrees. So we are on question 10 and we are told to find angle AOB. Okay, in finding angle AOB, you know that there is a chord AB which subtends an angle at the center of the circle here. It is at point O. and at the same time subtends an angle at angle ACB at the circumference of the circle. Okay, you know that twice the angle, or when a chord subtends an angle at the center of the circle, it is twice the angle it subtends at the circumference of the circle. So you can say that twice of what? Angle ACB gives us angle AOB. So angle ACB is 60 degrees. So we say that twice of 60 degrees gives us what? Angle AOB. So angle AOB is equal to 120 degrees. Now we are on question 11, and we are told to find angle MZY. Okay. Now we have angle ZOX to be 70 degrees. Okay. Now let's assume a line joins Z to X. Okay. Then realize that the line joining Z to X is what? Is a chord. Now we know that a chord subtends an angle at the center of a circle, and it is twice the angle it subtends, that same chord subtends at the circumference of the circle. Okay, so you can say that 2 times what? Angle ZYM gives us what? Angle ZOX. You can establish this equation, and it is true. It will be true. Okay. Why are we saying that? Because this chord here is subtending an angle at the center. The same chord is subtending an angle at the circumference of the circle. So twice the angle here gives us what? 70 degrees. Okay. Now how do we get ZYM? Okay, we just have to what? Divide both sides by 2. So we have twice of angle ZYM. Well, ZOX is what? 70 degrees. So dividing both sides by 2. So angle ZYM equals 35 degrees. Now, since we have ZYM equals 35 degrees, angle ZMY itself is 90 degrees. So when we add, since we have what? 90 degrees here and then 35 degrees here. We have 35 degrees here. Now we have this triangle, and 2 of the angles in the triangle has been what? Gotten. So we can what? Easily sum them up and deduct them from what? 180 degrees, because the sum of interior angle in the triangle is what? 180 degrees. So 90 plus 35 gives us what? 125 degrees. Now 180 degrees minus 125 gives us 55 degrees. So it tells us that angle what? MZY is 55 degrees. Okay, so we are on question 12, and we are told to find X and Y in this diagram. Okay, it's not difficult. The only thing is to apply the properties of circle theory and then analyze the diagram very well. Now, we know that when the chord subtends an angle at the center of the circle, it is twice the angle that same chord subtends at the circumference of the circle. Okay, so if this chord A subtends an angle X at the center, because we have O here, then it means that that same chord, at the same time, we can see that that same chord is subtending an angle at B. Okay, so it means that it will be half of what? X. Supposing if we have A here, then it means twice of A gives us what? X. So if we want to get the angle which is at what? Angle ABD, then we have to divide this by 2. Yeah. So we have A equals what? Half of what? X. So it means that angle ABD will be half of X. Angle ABD will be half of X. Because the same chord is subtending an angle at the center. At the same time, it is subtending an angle at the circumference. So twice the angle is subtends at the circumference gives us the angle it subtends at the center. Now let us assume that there is an imaginary chord here. There is an imaginary chord joining D to C. Okay, then we can say that, okay, since equal chord, we can say that this chord is subtending an angle at the circumference of the center. The same chord is subtending an angle at C. Okay. So the same chord subtends about two or more what angles. All those angles are going to be equal. But in this case, the same chord AD is subtending about two angles, which is angle ABD and then angle what? AC. So they are all going to be half of x, half of x. So if you have half of x here, you also get what? Half of x. That's nice. Okay. Then we can use a principle in plane geometry 1, which says that the sum of two opposite interior angles gives us one exterior. And I normally used to explain to my students that if they find it difficult to use that property, they should try drawing an L alongside those what angles. That is, when you try drawing an L from half of x, meeting 60 degrees, and then crossing it, then it means that an angle will appear here. So it means that this part is going to be 60 plus half of x. This angle. We also know that vertically opposite angles are equal. So this angle we see will be equal to this angle plus half of x. So you get 60 plus half of x. Now let us look at another thing. We have this chord here called AB. It's subtending an angle at D. The same chord is subtending an angle at what? C. Okay. So if it subtends y degrees here, then it will also subtend the same y degrees here. It makes an angle here. The same chord also makes an angle here. So we are going to have y degrees here. Now let us also assume that there is a line from the center which meets C. Okay, and that line is definitely going to be a radius. Let us assume that. Then the line from O, which meets C, becomes what? The radius. Now, we can also see that chord DC is subtending an angle at the center of the circle. At the same time, it's also subtending an angle at the circumference of the circle. At what? At A. It subtends an angle at O. Chord BC subtends an angle at O. At the same time, it subtends an angle at A. Then what's happening? It means that twice the angle it subtends at the circumference of the circle is going to be the angle that same chord subtends at the center. Therefore, if you have 60 degrees here, then twice of 60 degrees gives us 120. So we are going to get 120 degrees here. 120 degrees here. And since the line from O to C is a radius, and from O to B is also a radius, this triangle becomes what? An isosceles triangle. Therefore, two of its base angles will be equal. So when we deduct 120 from 180, we get 60. Then the 60 will be shared among these angles. So we have 30 here. We also have 30 here. We have 30 degrees. Now let us look at something. Let us come back to chord DC. Chord DC is subtending an angle at B to be 30 degrees. Okay. The same chord DC subtends an angle at A. Okay. So if you have here to be 30 degrees, then this side will be 30 degrees. Then let us try something. We can use the sum of two opposite interior angles gives us one exterior in this case too. For us to get this angle, that is 30 plus y. If you try drawing our L on this side, we are going to get our angle here, which is 30 plus y. Vertically opposite angles are equal. Therefore, we can also say that this side is also 30 plus y. Okay. Now, this is very, very interesting. Now, let us look at something. How are we going to get this angle? If we're able to get this angle, it will help us in our analysis. Now, how are we going to get that angle? We know that chord DC subtends an angle at the circumference of the circle to be what, 30 degrees. That same chord DC is subtending an angle at O. At O. So it means that twice the angle it subtends at B, this chord DC subtends at B, will be the angle it subtends at what? At O. Therefore, we are going to have 60 degrees here. We're going to have 60 degrees. I'm going to get to 60 degrees here. This is very, very nice. Now let us analyze our diagram very well. We have 30, 60 plus half of x and then y. We also have 30, 60 plus half of x and then y. It means that this triangle is the same as this triangle. So when we have triangle A here, it's the same as we have triangle A here. Now we also have 60, 30 plus y and then half of x. We also have 30 plus y, half of x, but we don't have anything here. But definitely this angle is also going to be 60 because this chord is subtending 60 degrees here. That's called BC. Subtends an angle of 60 degrees here. The same chord BC will also subtends an angle at E. Okay, so at here too we also have what? 60 degrees. Okay. Now, so 30 plus y, you have here half of x and then 60 degrees. You have 60 degrees, half of x and then 30 plus y. So if this triangle we have here, this triangle we have here is B, then definitely this triangle is also going to be what? Triangle B, because they are going to be similar. Therefore, A plus B will be equal to A plus B. Now, what are we getting here? It means that this whole big triangle we have here is just a reflection of this triangle. So we can say that triangle ABD is equal to triangle BBC. Since those two triangles are the same, then it means that we can draw some conclusions that length AD is equal to length DC, and then length AB is also equal to the length BC. Therefore, this one is a chord, this one is also a chord. Okay. Therefore, if length AB is equal to length BC, then it means that we have equal chords. And we know that there is a property in circuit theory which says that equal chords subtend the same angle at the center of what? A circle. So if we have this chord AB and chord DC subtends an angle at the center to be what? 60 degrees. Chord AB will also subtend the same angle at the center of the circle according to the property. Therefore, we know that x is also going to be equal to 60 degrees from our illustration, from our example, from our analysis. Now, how can we get y? We can get y by summing up all the angles here and then equating it to 180 degrees. That is, we have 30 degrees plus 60 plus half of x plus y equals what? Equals 180 degrees. Okay, now half of x, which is half of 60, is 30. Therefore, 30 plus 60 is what? 90. 90 plus 30 gives us what? So we have 30 here plus 60 plus what? 30, which is half of 60 plus y equals 180 degrees. Therefore, we have what? 30 plus 60 gives us what? 90 plus 30 gives us what? It gives us 120. So here we have 120 plus y equals 180 degrees. We have y equals 180 minus 120. This gives us what? 60 degrees. So this is very interesting. Y is 60 degrees. X is also 60 degrees. So sometimes we have to analyze the diagram very well and see whether if the triangles we are having are similar, then we can apply equal chords and then other stuff like that. So when you get a diagram like this, we just have to take our time and analyze the diagram by using the properties of the circuit. So we are on question 13 now, and as you can see, we have a diagram on the board and we are told to find y, z and then x. Okay, we have to do some analysis first. Okay, we can start by drawing imaginary lines. Okay, and then using the imaginary lines to draw some conclusions. Okay, now let us assume that there is a line that joins E to B. Okay, let's assume there is a line that joins E to B. Okay, short dashes. In that case, we have a triangle EOB. Okay, we have triangle EOB, and we can say that triangle EOB is an isosceles triangle. It will be an isosceles triangle because we have the center here, and then the line OB is a radius, because a line from the center to the circumference gives us what? A radius. Okay, and then line OB is also going to give us a radius. Now, since the triangle EOB, okay, two of its sides are what? Are equal. We can say that is what? An isosceles triangle. Since it is an isosceles triangle, then two of its base angles are going to be what? Equal. Now, we have the top angle for the triangle here to be what? 50 plus 70, which is what? 120 degrees. When we deduct 120 from 180 degrees, we are left with 60 degrees. Okay, so let's assume if there were to be some angles here as A and then A, then the sum of these two angles are going to be 60 degrees. Okay, so when we have 2A, when we sum them up, we are going to get 2A. Okay, so 2A is going to give us what? 60 degrees. When you divide this out by 2, you get what? 30 degrees. So A gives us what? 30 degrees. This tells us that the A we have in the diagram here is what? 30 degrees. So we have 30 degrees here and then 30 degrees here. Now, if we are able to get this angle, we can use a property, that is angle EBC. If we are able to get angle EBC, we can use a property in the circuit theorem to get angle what? EBC. And then use the isosceles triangle we have here to get Y and Z. But how do we get angle EBC? We know that angles on the straight line add up to 180 degrees. So we have 70 degrees here. For angle AOB, we have 70 degrees there. Okay, then how can we get angle BOC? We can get angle BOC by deducting 70 degrees from 180 degrees. Because the angles here are formed on what? A straight line. Okay, so when we deduct 70 from 180, we get 110. 110 degrees. Now, also we have radius OC, because there's a line from the center to the circumference. So radius OC and then radius what? OB. Okay, and they are forming a triangle. So this triangle also gives us what we call an isosceles triangle. And two of its base angles are going to be equal. So when we deduct 110 from 180, we get 70. So these two angles, when summed up, gives us what? 70. So when we divide them by 2, when we divide 70 by 2, we get 35. That's each of the angles here is going to be 35. So we have 35. So we now have angle what? EBC. We have angle EBC now. Since we have angle EBC, we can easily get what? Angle EDC. Why? Because when assuming we have a chord, okay, and the chord is what? Subtending angles at opposite segments, the sum of those angles should be equal to what? 180 degrees. That's a property in circuit theory. So when we have 180 degrees, when we sum x plus 30 plus 35, we have to get what? 180 degrees. Now 30 plus 35 has to be is what? 65 degrees. Okay. So we have x plus 65 degrees. The angle x we have here plus the 65 gives us what? 180 degrees. So x equals what? 180 minus 65. So 180 minus 65 gives us 180 minus 65. It gives us 115. So this tells us that x is equal to what? 115 degrees. We have x to be 115 degrees. Now, fortunately on our part, the x angle is found in an isosceles triangle. So we can easily deduct 115 from 180. And then the remaining angle is going to be shared among y and z, because two of its base angles are going to be what? Equal, as for an isosceles triangle. So since y is equal to z, let's quickly deduct 115 from what? 180, and that simply gives us what? 65. Then if we have 65, then it means that since y is equal to z, we can quickly what? Divide 65 by what? By 2. And 65 5 divided by 2 gives us 5 divided by 2 gives us 32.5. So it means that each of these angles we are going to get 115 and then 32.5. So here we have s equals 115, y to be 32.5, and then z to be 32.5 degrees. Okay, so this question is very easy. The only thing we have to do is, normally when you get questions like this, try drawing imaginary lines and then use either your plane geometry 1 property or your circuit theory properties to analyze the problem. Then by so doing, I hope you are going to arrive at the final answer, as we've also done. So we are on question 14, and question 14 says that ABC is an equilateral triangle inscribed in a circle. CD is a bisector of angle BCA, meeting the circle at B. E is any point as shown below. Find angle AE. This question is very easy. Okay, if you get a better understanding of this question, then you have to know what an equilateral triangle is, the properties of the equilateral triangle. You know that the interior angles of an equilateral triangle are all equal, and they are all equal to 60 degrees. Okay, therefore, if CD is a bisector of angle what? BCA, then it means that each of these angles here is going to be 30 because it bisects it. It bisects what? The angle BCA. So we can have 30 here, 30 degrees, and then also 30 degrees here. Okay. Now we are told to find what? Angle AED, which means that this angle. Okay. Now let's assume there is an imaginary chord joining D to A. We have chord BA subtending an angle at C, which is 30 degrees. Since the same chord is also subtending an angle at E, we can also say that then angle what? AED or DEA will also be what? 30 degrees. So, in short terms, our solution, we've gotten the solution to the question. Okay. Since we were having what? An equilateral triangle inscribed in the circle, we knew that each interior angle of an equilateral triangle is going to be 60 degrees. Therefore, since DC, line DC bisects one of the angles, it gave us what? 30 degrees each. And then we were also having what? A chord, an imaginary chord. When the same chord subtends as much as about 2 or 3 angles, when it subtends 2 or 3 angles, we can say that all those angles are going to be equal. With this one, it was subtending 2 angles at the circumference of the circle. So we can say that if DA subtends an angle at C to be 30 degrees, the same for DA is also subtending an angle at E. Therefore, that angle becomes what? 30 degrees. So our final answer, which the question is asking us, find angle AE, angle AED, angle AED gives us what? 30. Question 15 is telling us to find this x as our variable. Okay. Now we know that a diameter subtends an angle at the circumference of the circle to be 90 degrees. Okay. So since we have BC, a diameter here, subtending an angle at the circumference of the circle to be 90 degrees, we are going to have 90 degrees here. But this diameter here, subtending an angle here. So we have this angle to be 90 degrees. We have this angle to be 90 degrees. Okay. And then we also know that when a chord subtends angle at different segments, okay, then we can sum up the angles at those 2 different segments and it will give us 180 degrees. This chord here, DB, or DB, is subtending an angle at DAB to be 120 degrees. Okay, the same chord is also subtending an angle at C. Okay, Then the sum, according to the property in circuit theory, the sum of this angle, that is angle DCB, plus the angle in DA, that is 120 degrees. The sum of those two angles should give us 180 degrees. Okay. So we know that